welcome to the Junior Astrophysics. This is Akash. We basically look at a lot of astrophysics and other kind of advanced physics. But now, to understand that kind of physics, we need an understanding of the basic physics. And basic physics is mostly about motion physics and other kind of physics. Atomic physics, there are many. Now, let's have a video looking at motion physics or kinematics. So let's begin. Now let's begin with the equations. We focus on motion physics or kinematics. So this will be our heading. So kinematics deals with the motion of bodies. So the first parameter we're going to take a look at is speed. So speed is a very common term we use in our regular life. Like if someone's going really fast, we say they're moving at a really high speed. And if they're moving really slow, they say they're moving at a really low speed. So when going into physics, we consider speed as the distance traveled in a certain amount of time. Or as an equation, we can say speed is equal to distance by time. So this is the first equation in kinematics. Speed is equal to distance into time, distance by time. Now let's take a simple look or an example for speed. Now let's say that there's a car. And that car is traveling a distance from point A to point B. And the distance between A and B is around 20 kilometers. And the time he takes is 10 hours. Firstly, logically, when we look at 20 kilometers in 10 hours, we can say that he's moving really slow. Really slow means really slow. Okay, so his speed is very less. Now, let's use the equation of speed now. As we can see, speed is equal to distance by time. So speed is equal to 20 by 10. 2 kilometers per hour. Now, the unit for speed is kilometers per hour, or, just giving an or, meter per second. It depends. Now, if we're having 20 meters over here and 10 seconds over here, our answer is going to be 2 meters per second. It depends on the units given. So the next equation we're going to be looking at is velocity. Now velocity is somewhat the same as speed. But the only difference is that speed is a scalar quantity and the velocity is a vector quantity. I'm not going to go into detail about vectors and scalars for now because I'm going to be making another video on vectors and scalars. So for now, let's just take a look at the equation. So velocity is the displacement traveled in unit time. So as you can see, speed is a scalar quantity. So distance is also a scalar quantity. And since velocity is a vector quantity, displacement is a vector quantity. Now, as I already said, told you, we're gonna have a look about scalars and vectors in another video. Now, so we don't really have to take a look on an example for velocity because it is the same as speed. It's just the same equation, okay? So now let's take a look at acceleration. So the equation for acceleration will be delta V upon delta T. Now, delta means change in. So if there's a change in velocity or speed, okay, we can say delta V. And if there's a change in time, we say delta T or change in time. Now, as we already saw, velocity is the distance traveled in a certain amount of time. And acceleration is the speed in a certain amount of time, the change in speed, increase or decrease. That can be anything. In other words, we can define acceleration like this. B minus u upon t. Now, b is the final velocity and u is the initial velocity. So if there has been an increase in the acceleration, we're going to have final velocity minus initial velocity upon time. Let's take a really simple example, really simple. Now, acceleration, we have to find. So let's consider that the final velocity, or let's take point A and B. Velocity at B and A. So at B, we're having the velocity of around 20 kilometers per hour, and at A, we're having around 6 kilometers per hour. Now, this becomes the final velocity, and this becomes the initial velocity. So 20 minus 6. Now, let's consider the time taken is about 10 hours. By 10, I'm going to get 14 by 10, or 1.4 meter per second squared. So the equations we've seen until now are 1 for speed, 2 for velocity, 3 for acceleration. Now for speed, we saw distance by time. So distance is denoted by s and time is denoted by t. You may wonder why we don't give d for distance. It is because in calculus they use something called the derivative operator, in which they use d. So now we use s for distance. Next, in velocity it's the same as by t, because s is for displacement and t is for time. And for acceleration we have delta v upon delta t, which is delta velocity by delta time, or change in velocity by change in time. These equations can be rearranged to get other values such as distance and time, displacement and time, and change in velocity and change in time. It's just simple rearrangement. Now let's get into the next set of equations we have. So there are more equations for velocity. Let's look at one of them. So the first equation is b is equal to u plus at. So this is for the final velocity. Okay, it's final velocity. Now the final velocity is equal to initial velocity plus acceleration multiplied by time. I could change this into words if you would want. So it's final velocity is equal to initial velocity plus acceleration into time. I'm not going to work on any examples because I think you would have understood what is initial velocity, acceleration, time, and final velocity, and all the operations. So you can just find the final velocity using this expression. Now, there is another expression. So this expression is derived from this. So v squared is equal to u squared plus 2as. Now this is the square of final velocity. This is the square of initial velocity. This is acceleration, and this is displacement. Now using this, we can find the square of final velocity. But if you want to know how to find just the normal velocity, you can do this. Root of u squared plus 2as. Just simple mathematics. And again, this is displacement, acceleration, initial velocity, and final velocity, as you can see over here. Now, using the equation is based on the question you have, or the data you have. So if in your data you don't have time but you only have displacement, you can use this expression. But if you don't have displacement but you have the time, you can use this expression. But if you have displacement and time, you can use this expression. It is based on the data you are being given. Now, let's look at one expression we have for displacement. S is equal to ut plus 1 by 2 at squared. I think, as you know, this is displacement. Okay. This is the initial velocity. This is the time. This is addition. This is half of acceleration multiplied by time squared. Or this can also be written as displacement is equal to ut plus at squared by 2. Both are the same things, just expressed in a different way. So this is the final equation for these current things we're working on in motion physics or in kinematics. So we can stop over here. Thank you. So I'm sure that by now you might have understood the basics and the basic equations of kinematics. So I'm sure you've been looking forward to my next video. Drop a like, share, and subscribe, and have fun learning. See ya. Bye, guys.